Hello. Okay, so hello. Today we're going to discuss about the wave properties of light. This is the second discussion about the topic. So we have here, last time we discussed about the introduction and we have the infraction of light. So we have here, okay. So let's first have a review. So we have here our interference of light. It happens when two light waves meet. So we have here constructive interference and we have what we call also the destructive interference. So we already know na constructive interference, those are waves that are in phase. So when you say in phase, so those are waves that are the crest and the trough are on the same direction. Example, this is the first wave. Okay? Then we have your second wave. So nag-meet, the same sila og direction sa ilang crest and cross. So if you have the constructive interference, this wave A, then this wave B, ma-add na sila duha, that will be A plus B. So maka-form din siya og bigger na wave, interference na wavelength. Okay, so inani ang iyang mahitabo. On the other hand, when you say about destructive interference, waves are said to be out of phase. When you say out of phase, the troughs and the crease and the troughs are on the opposite direction, or parang example, we have here our wave A and we have here our wave B. Sinani, nagtagbo siya. So if you're going to add this one, okay, so if this is our wave A, this is our wave B, if i-add na siya, okay, ang ma-form na niya kay nani siya. That's why it is called destructive interference. The waves are out of phase because if i-add mo sila, they are on the opposite direction, okay? Na siya. So ang ma-form na niya kay marag zero na siya or less ang iyang wave nga ma-form. Okay. Then we have here our common lighting devices to demonstrate interference is laser. So naka-mention ko last time na a best example to discuss or to describe interference is ang application sa laser. So laser possesses properties that make it consistent and reliable in showing how light behave as a wave. So laser light is directional. Take note, it is directional. So if natay laser dire, ang iyang light ana kay straight lang yun na siya. Kung asa nimo siya a point. So ana siya straight lang yun ang iyang ano. Not like sa to ang light bulbs. So ang light bulbs nato is okay. So ang light bulbs nato okay. So if this is our light bulbs, ang iyahang light ana is naka-scatter. Okay? So, ang sa laser light, direction na lang yun siya. Kung asa siya i-point kay mo lang yun na iyahang one direction. So, ang sa light bulbs kay naka-scatter siya. So, it is made up of coherent waves with the same wavelength and are in phase that result in a concentrated light on a laser beam. So, take note, it is in phase. That's why it is constructive. Constructive interference ang ato ang laser light. Okay, so Thomas Young is the one who worked with, one of the scientists who work on the interference of light. Like, he is one of the scientists nga nag-make og experiment or naghatag idea about the interference of light. So he made an experiment that is known as the double slit experiment. So sa iyang experiment, he said here that if nalang daw kay one split I mean, muna siya if na kay light moagi siya ana nga split is na siya wave nginani. If na daw kay duha ka light, I mean duha ka split or duha ka kanang murag agian sa light. Okay, so kini daw siyang ano, 'di ba, magbuhat man siya ginani individually. So kini po siya magbato ginani. Kini daw silang duha ka waves is mag-interact with each other producing, okay? Mag-produce na po na sila another waves, okay? So naay murag interaction between waves. So I want you to watch this video here. Mo na siya ang link sa video. So nice ang iyang explanation about sa double slit experiment. Okay, now let's proceed with the diffraction of light. When you say diffraction of light, it happens whenever waves bends or spreads. Take note, wave bends or spreads around the edges of opening or opaque obstacles. So the amount of diffracted light waves varies in the size of light, wavelength, and the size of the opening. So it varies with nitrate duha condition. It varies sa size sa light's wavelength and sa opening. Okay, mo na siya ang duha ka factor nga maka-affect sa tuang diffraction of light. And take note that light waves will be more diffracted, okay? More diffracted as they pass through a narrower slit. Okay? So more diffracted siya if maagi siya narrow slit. If maagi siya wider slit, then less ang iyahang diffraction. And we have here an increase in wavelength also increase the amount of diffracted light. So there is an direct relationship between the wavelength and okay, wavelength and we have diffraction. Okay, diffraction. So if ang isa is mag-increase pod ang if ang mag-increase ang wavelength, increase pod ang diffraction. If mag-decrease ang wavelength, mag-decrease pod ang diffraction. So diffraction shows that an object along the path of light rays cannot stop the rays. So take note that an object cannot stop the rays on if na maagi na siya. Then, long wavelength yields patterns that are broader and produces fringes that are somehow blurred and vice versa. So, again, take note ha, long wavelength, maproduce siya og blur nga fringes. And if dili po siya long or short lang siya, then dili po siya blur or mas clear siya. Okay? Then we have here diffraction grafting. So an instrument that allows people to observe diffraction and interference of light. So it is consists of large number of equally spaced parallel slits. Take note, we have here equally spaced, okay? Equally spaced parallel slits. Now, the grafting spacing, or we have here D, that is the measurement of the distance between the slits. Okay, wait for a while. Okay, so mo to siya. Ang D na to is ang measurement of the distance between the slits. So we have here when waves of a particular wavelength, okay, wavelength is denoted by lambda. Okay, that is lambda. And are incident normally upon a grafting spacing D, brightness is observable beyond the grafting at angles to the normal, wherein n lambda or n times lambda is equals to D times sine theta sub n. So itong theta is mo na siya ang angle na mag-create. Take note here that our n is the order number of the diffracted images, okay? That is the order number. So we have here diffraction through a single slit happens when parallel light or parallel rays of light on a particular wavelength are incident normally upon a slit of a certain width. So diffraction of light patterns is observable beyond the slit, whereas complete darkness can be observed at an angles to the straight beam. So complete darkness is observable at an angles, okay, to the straight beam. So if we have darkness ang gina-measure or like darkness ang given, dili brightness, then ang n is the order number of the dark band of the or in the diffraction. So the same pa rin, order number lang gyapon siya. The same formula but ang n is ang dark band na siya, order number of the dark band. Okay, so let's proceed with the next. So we have here our example to understand. So we have here a grafting. Okay, this is grafting. Yeah, a grafting. Okay, that is grafting. Containing 4,500 slits per centimeter is illuminated with a monochromatic light and produces the second order bright line at an angle of 45 degrees. What is the wavelength of the light used? Okay, now let's write our given first. Okay, given. We have here our, okay, slits per centimeter. That is our x. Okay, that is our x. That is 4,500 slits per centimeter. Now, take note we have here, again, our formula is n lambda is equals to d sine theta. So with our given, okay, wait lang. Okay, so with our given here, oops, wait lang ah. Okay, so with our given here x equals to 4, 5, we also have here our second order, okay, n, so n will be equal to 2, and we have angle is equal to 45 degrees. So now using our formula, we have, okay, n lambda is equals to d sine theta. So take note na itong d, okay, that d is equal to 1 over x. So we have here 1 over 4,500, that is equal to, approximate natin siya into two decimal places, that will be 2.22 times 10 to the negative 4. So muna na siya to ang given. Now, wait lang. Okay. Okay, so now we have here our given. Now let's proceed with our solution, or I mean, let's proceed with the, sorry. Okay. So we have here this equals to 1 over x equals to 1 over 4,500. Approximate natin yan into 2. Okay, that is approximately 2.22 times 10 to the negative 4. So, pwede na din nato ni siya ma-substitute. Okay, sa ito ang formula. We have n. Anong n natin? We have 2 times ato ang lambda, wavelength. Wavelength is unknown. Okay, wavelength is unknown, or we have the lambda. Okay, so that is d natin is 2.22 times 10 to the negative 4 times sine, okay, sine 45 degrees. Okay, that will be now wavelength is equals to, copy ang numerator, 2.22 times 10 to the negative 4 times sine 45 divided by 2. Okay? Now, take note na gi-divide na to ni siya by whole, ang whole expression by 2. So, we have now lambda is equal to, okay, approximately this is equal to 7.85 times 10 to the negative 5. Now, take note here that one angstrom, okay? I mean 1 angstrom, like this, mana siya yung notation. 1 angstrom is equal to 10 to the negative 10 um, meters. Okay, wait, let me check nanometer. Okay, that is equal to, okay, 10 to the negative 10 meters. So that will be, okay, that is equal to 10 to the negative 10 meters. Now, kung saan na to ni siya pag, like, we need to convert this one into angstrom. So that will be now, I mean, lambda, or our wavelength, that will be 7, okay, 7.85 times 10 to the negative 5 divided by 10 to the power of negative 10. So that is equal to 785,000 angstrom. Okay, so that will be the wavelength of light. Muna siya ang wavelength sa ato ang light. Gigamit ani nga grafting. Okay, so inana mag-solve. Okay, so inana mag-solve ha. So let's proceed with the next one. So we have here example number 2. A monochromic light with a wavelength of 3.5 times 10 to the negative 8 meters strikes a grafting. Okay, wait. Grafting or grating yun ni siya. Wait lang. Okay. So this is a grating yun di ay. Okay, tama din siya, dili grafting. Okay, so katong ganina sakto din ni siya. Dili na siya grafting. Ana ra gyud din siya. Okay, so muna siya. Okay, balik ta sa itong example number 2. A monochromatic light with a wavelength of 3.5 times 10 to the negative 8 meters strike a grating containing 10,500 slits per centimeter. Determine the angular position of the third order bright line. Take note, third order. So we have here our given, that is n is equal to 3. We have a wavelength or lambda is equals to 3.5 times 10 to the negative 8 meters. And, okay, we have here our d. Okay, our d is 1 over x. Our x here is 10,500. So our d now will be 1 over 10,500. That is approximately, okay, 1,000 over, 1 divided by 10,500. That is equal to 9.52 times 10 to the negative 5 approximately. 9.52 times 10 to the negative 5. Then, okay, we have now our given. We can now write our formula. N lambda is equal to d sine theta. So we have here our n, that is 3 times our wavelength 3.5 times 10 to the negative 8 meters is equal to d, that is 9.52 times 10 to the negative 5 sine theta. Now, we have here divide the whole expression by 9.2 times 10 to the negative 5. That will be sine theta. It will be equal to 3 times 3.5 times 10 to the negative 8 meters. O pwede na dili apilon ang meter. Okay, sige lang, apilon na lang na to. Over 9.52 times 10 to the negative 5. So we have here theta is equals to sine inverse. Okay, we have 3 times 3.5 times 10 to the negative 8 all over 9.52 times 10 to the negative 5. So this is approximately, so we have sine inverse, okay, 3 times 3.5 times 10 to the negative 8 all over, it will be 9.52 times 10 to the negative 5. So what will be your answer? That is approximately 0.06. 0.06. So muna siya ang angle, okay, na or ato ang angular position nga mag-determine sa atong third order bright line. Okay, let's proceed with the next one, last example. A monochromatic light with wavelength of 600 nanometer Take note na nm is equal to 10,000 negative 9, 10 to the power of negative 9, strikes a grating and produce, okay, strikes a grating and produce the fourth order bright line at an angle of 30 degrees. Determine the number of slits per centimeter. So our given here, okay, so our given, that is, we have here our wavelength, that is 600. Okay, 600 nanometer. How are we going to convert this into 10 to the since i-convert na to siya, dapat i-multiply na to siya 10 to the power of negative 9. That will be times 10 to the power of negative 9. That will be 600 times 10 to the power of negative 9. That is equal to 6 times 10 to the power of negative 7. Okay. Nanatay wavelength, our n is fourth order. So we have n is equals to 4 and our angle is 30 degrees. So itong pangitaon is ang x. Okay, ang slits per centimeter. Now, so we have here, take note na if ang d nato is 1 over x, so ang x nato is 1 over d. So x is equals to 1 over d. So our formula, that is n times lambda, is equals to d sine theta. So let's substitute our given. N is 4, wavelength is 6 times 10 to the negative 7. We have here our d, that is a known d. Then we have sine, atong theta is 30. So we have d is equals to 4 times 6 times 10 to the negative 7 over sine 30. So approximate na to atong answer. That will be 4 times 10 ay 6 times 10 to the power of negative 7 all over sine 30. So that is approximately, okay, 4.8 times 10 to the power of negative 6. So equal ni siya. That is equal to 4.8 times 10 to the negative 6. Now, our x is equals to 1 over d. So we have x equals to 1 over d. That will be now 1 over 4.8 times 10 to the negative 6. So that will be equal to, or approximately, okay, that will be 1 over 4.8 times 10 to the power of negative 6. So that will be now equal to, okay, approximately na to sa whole number, nearest whole number, it is 208,333 slits per centimeter. So, muna siya ang number of slits per centimeter sa atong fourth order bright line. Okay, question with the discussion will be addressed. Uh, you can comment or you can message me if you have question about our discussion for today. So please message me during the work hours from 7 a.m. to 5 p.m. Pwede ko maka-entertain ng questions until 7 p.m. Okay, but do not expect na paspas akong reply. Okay, so mo to siya. Again, if you have question, you can message me. And reminder sa inyong short quiz and long test. God bless everyone. Thank you. Bye-bye.